Welcome to the video tutorial for the SINUMERIK 828D CNC controller. This tutorial provides more information about programming in the CNC editor. You'll become familiar with the editor and the Siemens CNC programming language, and learn more about the cycle support with Program Guide. With the geometry processor, you'll create a contour, program repetitions, and finally simulate the machining. With the help of a simple sample workpiece with contours, pockets and drilled holes, let's create a sample NC program from the drawing. First, change to the Program Manager to create a new NC program there. Select New, then Program Guide G-code and enter a name. Click OK. The editor opens automatically. The editor supports DIN ISO code, technology cycles, and Siemens high-level language programming with parameters, variables, and structures. The soft keys provide you with the usual editor functions, such as copy, cut, or renumber. You can call and parameterize cycles for the widest range of drilling and milling machining using the horizontal and vertical soft key bars. It's best to first define the raw part. This is necessary for a complete representation of the simulation. To do this, select the Various, then Raw Part soft keys. In the dialog, you can select predefined raw parts and enter the dimensions. Static and animated help pictures support you during parameterization in the dialogs. Click Accept to save the inputs. Now we've defined the raw part, let's create the tools required for the milling. Click Select Tool and navigate with the arrow keys to an empty magazine slot. Click the New Tool soft key. The tool list provides you with a catalogue of the most common tool types, such as drill, milling cutter and probe. First, select a tool type, and then enter the required parameters, like length and diameter. Click to Program to add the tool to the program. Once the tool has been added, specify the 0-point offset and the technology values. Then program the contour. You can create the outer contour as G commands or by using the geometry processor. The geometry processor is a good example of how easy it is to program contours. To do this, first create a new subprogram with the name Contour. In the subprogram, open the Contour editor using the Mill Contour and New Contour soft keys. You can now use the vertical soft key bar to create various geometry elements, like straight lines and arcs. In this example, you see that first a straight line in Y and then a straight line in X are created. The complete contour then consists of individual geometry elements. Click Accept to transfer the individual contours. You can use the arrow keys to navigate through the individual contour sections and change or delete existing sections. Close the subprogram with M17, change to the Program Manager, and open the main program. You can now call up the subprogram you've created with the contour descriptions in the main program. To do this, select Mill Contour, then Contour, and then Call Contour. Enter the name of the previously created subprogram. Click Accept to close. The SINUMERIK Program Guide provides powerful milling cycles for milling the contour. As an example, let's parameterize a path milling cycle. Select the Mill Contour, then Path Milling soft keys. The cycle opens. The Program Guide technology cycles have a similar logical structure which simplifies the programming. After just a short time, you can effectively create NC programs. In the upper part of the cycle, you can parameterize basic declarations, such as machining and retract level, and machining strategy. In the middle part, you'll normally enter the geometry data, such as depth and dimensions. The lower part contains special parameters, such as strategies for approach and withdrawal or immersion. The parameters are checked during input, and ambiguous or missing parameters are marked red. This means errors can be avoided in advance. Click Accept to add a cycle to a program. Now parameterize this machining step in the displayed dialog. Enter the retract level, the feed, the depth in Z, and the approach and retract mode. Animations and help pictures simplify parameterization and clearly explain the options. Click Accept to add the cycle to the program. A newly created cycle is shown colored in the DIN program and begins with Cycle. You can reopen and machine a cycle at any time. As the next step, mill the two circular pockets. To do this, use the special pocket milling cycle. First, select a tool from the tool list. A shaft milling cutter with diameter 10 is used. Next, select Milling, then Pocket, and then Circular Pocket. In the cycle, select the machining level, the milling technology, and enter the dimensions of the circular pocket. You can parameterize various strategies for immersion. Let's use helical. This is also shown clearly in the animation. Click Accept to transfer the cycle to the program. Parameterize the second circular pocket similarly. Just enter a different value for depth and diameter. This completes the programming of the circular pockets. Program Guide also provides an additional cycle for the circular groove. Enter the geometry data. Because only one circular groove is to be milled, select Full Circle and enter 1 as the number. You can also program several circular grooves on an arc with this cycle. Click Accept to complete this parameterization. In the next work step, the drilled holes will be centered and the drilling cycles parameterized. Call the drilling cycle using the drill and then drill ream soft keys. Parameterize the drilling depth, the drilling strategies, and select the position pattern mcall. Then enter the 4 drilling positions and bracket the machining with mcall. The drilling cycle is used on each of the positions. Use the drilling cycle for the arc too, but now use the option of predefined hole circles in combination with labels or tags. Use the drill, then positions soft keys to add a new position cycle. Select Full Circle and, under Lab, enter the tag for the repetition of the position pattern. Now create an arc with 5 holes. The drilling cycle is now used for the drilling positions. You'll have set the tag circle because a thread should also be tapped on the drilled holes of the position pattern. In the program, you see that the circle tag is used for each of the centering, drilling, and thread tapping actions. You only need to program the positions once, and can use these as often as required in the program. Finally, we show the cycle for thread tapping. This is parameterized similarly to the drilling cycle, but provides a wider range of capabilities. You can, for example, select whether or not compensating chucks are to be used for the machining. Depending on the selection you make, the number of possible parameters also changes. The drilling task variants are particularly relevant for practical application. Depending on the material, you can parameterize whether the thread should be drilled on a cut or with chip breaking. Finally, the program is simulated. The 3D simulation displays the machining simultaneously with the program execution, including the associated workpiece and tool. This allows you to quickly find any collisions or program errors. The simulation provides additional views, such as 2D and zoom or cross-sections. After an error-free simulation, the program can be run on the machine. In conclusion, we'll briefly summarize the advantages of graphical programming. Unbeatable command scope for flexible and time-optimized parts programs. Program guide graphical cycle support as an extension to the highly flexible Siemens CNC programming language. Faster programming thanks to the powerful CNC editor. And simple contour input with the geometry processor painting by numbers. Thank you for your interest in this video tutorial.